Okay, good evening everyone. How are you all? There was a slight issue with the connection, so I had to disconnect and then connect it again, and hopefully this should work fine now. So let's wait for 2 to 3 minutes. Let the other students join here. Okay, all those students who have already marked your attendance before, no need to mark. Otherwise, all those who are joining right now, they can write their name, class and section. Okay, in the last class, we've studied about friction, and we also talked about what are the advantages and disadvantages of friction. In this class, we will continue, and I will repeat the last 2-3 slides that we covered, because I guess the voice isn't so clear. So if you can let me know if you're not able to hear clearly. Okay, fine. So we were discussing and we talked as to how the friction, gives rise to heat, how it produces heat. And we spoke that, when we rub our hands, suppose our hands are rough, and they are not wet, we have not applied any oil or any cream on our hands. So the hands are rough, they are dry, and when we rub our hands, what happens is slight amount of heat is produced. Okay. Why is that? Because the surface of our hand is rough, and any rough surface, when it is rubbed against another rough surface, then it gives out heat. Okay. So in winters, you can take production of heat as an advantage of friction, but otherwise production of heat because of friction is actually a disadvantage. Okay. Now, so heat is produced in your electrical appliances also, like your mixer and grinder, like your washing machines, and anything which works for a long period of time, that will give out heat. Okay, so that is one disadvantage of friction. So let's also, so we were talking about the disadvantages. The first point that we spoke was production of heat. So these are the disadvantages. First is production of heat. Next was wear and tear. Wear and tear because suppose if you are using anything for a long period of time and we do not maintain that, we do not reduce the friction. If the friction is more, then generally it will wear and tear will take place. Okay. And last, what we discussed was the reduction in the efficiency. So suppose you have your bicycles, and if you don't oil your bicycles on time, if you don't apply any lubricant to it, and because of friction, what will happen is the efficiency will reduce. Okay, the efficiency is going to reduce. Fine. So this is what we discussed in the last class. Next is friction as a friend or foe. Okay, how can you have to, now in this case you have to write down few points in which you think friction will act as a friend, and a few points in which you think friction is actually our enemy. Okay, so in what all ways will it act as a friend? Firstly, it helps you in walking. Okay, then we are able to write because of friction. Where is the friction present when you're writing? When you're writing, between your lead of your pencil and between your paper, there is friction, so you're able to write it. Okay, if the paper is smooth, if there is no friction, you won't be able to write it because your pen or pencil is going to slip easily. Okay, so it is only because of friction that you're able to write. Next is you're able to dig any nails or the screws or inside any surface because of friction. Okay, next is lighting of matchstick. This also we discussed in the last class. So all these work we are able to do because of friction, because there exists friction, correct? How is it your enemy? Because wear and tear takes place. All the disadvantages you can put it inside the friction as foe. So you have heat being produced, you have wear and tear, okay, you have reduced efficiency is going low, you can have noise which is produced, noise because of friction. So friction can act as a friend, also it can act as a foe, correct? So these are the points that you have to keep in mind and note them down somewhere. Okay, now let's talk about what are the methods by which we can increase friction. What are the methods by which we can increase friction? Okay, all these students who are joining right now, you are joining very late, and next time onwards I want all of you to be on time. At the max 5 minutes late, 7 minutes late. You can't be as late as 15 minutes right now. Okay, so let's continue now. Let's talk about the methods of increasing friction. How can you now increase friction? Okay, so firstly you can actually make the surface rough if you want to increase friction, because you know that on a rough surface generally the friction will be very high. Okay, it will be more. How? See, if you see here, how do you play this game of kabaddi? You generally play it on a ground, over a muddy surface. Right now, in these days when they play, at a national level, what they have is they have those rugs, but those are also rough in surface. So that roughness actually produces friction, because of which they're able to have good grip on the surface, right? So making the surface rough, because any rough surface is going to have more friction. So I told you, the rougher the surface, the friction is going to be more. So you need more friction. Otherwise, if there is less friction, you would easily slip on the surface, correct? Now this also in the second, look at the second picture and the third picture here. So what do you see? You see these tires generally are tires of the car, tires of our bicycles and the tractors. They have got these designs over the tires. So why these designs? This is not just for beautification of the tire, but it is also because these designs make the surface rough. So they make the surface rough. By making the surface rough, what they are doing is they are increasing the friction, and by increasing the friction, they are going to have a good grip on onto the road. They will not slip easily. So at times what happens, over a prolonged use, these designs will actually fade away. So then we know that it is the time for us to replace the tires. Okay, also under your shoes, if you see the soles of the shoes, you will find such designs. Okay, so those designs are also for this very same purpose. You know that the designs is going to make the surface rough. So please note down all these points in this sequence only. The designs are going to make the surface rough, and because the surface is going to be rough, so it'll have more friction, and because of more friction, it is easy for us to walk on any surface. We won't be slipping. Okay, we can have a good grip of the surface. Now next, so first point is by making the surface rough. The next point that you're going to apply is by making the surface dry. Okay, suppose if the surface is dry, let's say at your homes, you see if there is water spilled on the ground, then the friction will be less, and then you can slip easily. So that's why we say we have to always keep the floor dry. Why? Because the dry floor is going to, if the floor is dry, then the friction is going to be more. If the friction is going to be more, then if the friction is more, I told you, what about the movement? Our movement is going to be less. So we will not slip. Okay, our movement will be restricted. Okay, so that's why to have the surface dry, it is very, very important. Okay, next, you can also do one thing, you can increase the weight also. Okay, look at this, the figure over here. If you have 50 kgs of weight, and let's say 5 kgs of weight. So if the weight is going to be more, then the friction is also going to be more. If the weight is going to be more, the friction is going to be more. So the movement is going to be less again. It will not move. It would require large amount of force. Okay. So how will you increase friction? You can increase it by making the surface dry, by increasing the weight, by making the surface rough. Fine. Now, what are the methods of now reducing the friction? So I've told you 3 points in increasing the friction. Now we've come to reducing the friction. How will you reduce the point? The points are exactly opposite to what we discussed in case of increasing. Firstly, you can use lubricants. Now understand what are lubricants. Lubricant is any substance which helps in reducing the friction. So what is the lubricant in case of our, let's say our sewing machine or our bicycles? We apply grease. So grease can be a lubricant. Oiling can be a lubricant. So you can use anything. In case you can see here this carom board, what do? We apply powder. Sometimes when you're not able to actually score well, what do? We just take the powder and we sprinkle it over the board. So what happens? That powder actually makes the surface very smooth, and when the surface is smooth, the friction is going to be less. And the friction is going to be less, so the movement of our striker or the movement of our coins is going to be very smooth, very high. Okay, so that's why, what are we doing by sprinkling powder? We are reducing the friction. What are we doing by applying the oil in this case? In the case of machines, by applying the oil, by greasing the machines, we are reducing the friction. So you have to apply lubricants. Okay. Understand the importance of lubricant. It can be a 1 marks question and very simple. What are lubricants, or give some examples of lubricant. Fine. So by applying lubricants, you can reduce the friction. Also, you can use what is called as ball bearings. I'm sure this you must have all seen, in various machines, and we'll understand the parts of the ball bearing also in the next slide. So you can use ball bearing. Okay, ball bearings are used in machines, fans and cycles. So what is ball bearing? Ball bearing is a device which is used to convert sliding friction into rolling friction. Okay, that means suppose something is sliding, it will convert that sliding movement into rolling movement, because rolling is the fastest. Suppose you have a box here. Okay, is it easy to slide the box on a smooth surface, or is it easy to just roll it over some wheels and then move it from one place to another place? Obviously it is easy to roll it. If you attach wheels, it will be easy for you to pull it, okay, than even sliding. Okay, so that's why the easiest one is rolling for us, right? Because rolling will have the least friction. Okay, so what the ball bearing does is the ball bearings convert sliding friction. Okay, this is sliding. Okay, sliding friction into rolling friction. Now understand the parts of the ball bearing. So I'm sure all of you must have seen these ball bearings. This is the outer ring of the ball bearing. This is the outer ring of the ball bearing, and you have an inner ring also. This is the inner ring of the ball bearing. And inside this, you have small metal balls. These are the metal balls which are separated by a metal block. Okay, and these metal blocks are called as separators. So this is a separator. So that's all. These are the only parts that you have. You have an outer ring, you have an inner ring, you have a steel ball, and you have a separator. That's all. And if you see, these balls will actually inside, they are rolling. Okay, they are sliding and they are rolling inside. So what this ball bearing does is, more than that, you need not actually go deep into the parts and the working of the ball bearing. This much is enough for you. Understand that and get to know that they convert the sliding friction into rolling friction. Okay, what is sliding friction? What is rolling friction? We are going to now talk about it. So by using the ball bearings, we are going to reduce the friction. Okay, so this is the second. So first one was using lubricant. Second one was using the ball bearing, by making use of ball bearing. Okay, so next, methods of reducing friction. You can use wheels, which is same as using maybe ball bearings, right? You can use Wheels. So this is self-explanatory, right? You can use wheels. Okay, this is the fourth one, and this may be new to you. By using air cushion. What is air cushion? Air is trapped. Just a second. Yeah. Air is trapped under this. You see this bag sort of thing, this tube sort of thing. Okay, right? So what happens is, this tube, when it is on the water, there is actually a small layer of the air which is between the water and this tube. So that air actually keeps it slightly floating over the water, right? So these air cushions are also used in many times in the aircrafts also, okay? Because there is air inside it, so it acts as a cushion. So it will reduce your friction. Okay, what happens when you wrap something using bubble paper? Bubble paper are also a kind of air friction only, correct? So you can use air cushions. So this is the third point. Fine. Now, next is how did you increase friction? By increasing the weight. So how will you now reduce the friction? You will reduce the friction by reducing the weight, just exactly opposite to what you did in the case of increasing friction. So another point can be, you can reduce the weight. If you reduce the weight, it will reduce the friction. Fourth point can be by making the surface smooth. In the case of increasing friction, what did we do? We increased the roughness of the surface. Now in this case, to reduce the friction, you will make the surface smooth. You will make it very shiny, very smooth. Because if smoother the surface, the friction is going to be less. I told you, rougher the surface, the friction is going to be more. Okay. How about in the case of weight? If the weight is more, then your friction is also going to be more. If the weight is going to be less, then the friction is going to be less. So you can play with the weight as well as the smoothness or roughness of the surface. Thereby you can reduce the friction or increase the friction. Fine. So this is, I hope it is very clear to all of you. Now let's come to static friction. What is static friction? First, understand what is the meaning of static. Static means something stationary, something at rest. Okay, this is something at rest, which means static. Dynamic means something which is moving. Fine. So static friction basically is a friction that exists between two bodies when the bodies are at rest against each other. Suppose I have a box here, and this box is kept on the ground. Now the box is not moving. So that means the box is at rest. When the box is at rest, I told you about the interlockings in the last class. So if the box or if any object is at rest, what will happen? Even the box will have some irregularities, right? The ground will have some irregularities here. So these irregularities are going to be perfectly locking against each other. Okay? They will be locking into each other. The irregularities will be locking into each other. Because they are locked, that's why the object doesn't move. So if we have to unlock the irregularities, what do we want? We have to apply some force in order to push this object and in order to unlock all those irregularities. Please understand this point very carefully. If you want to unlock the interlockings, the lockings, what you have to do is you have to apply force. If you apply force, your force is larger. So if you apply force, the interlockings will no more get interlocked and they will be free to move. So the object moves. Fine. So what is static friction? And look at this definition. Static friction is a friction that exists between a stationary body and the surface on which it is resting. It exists between this box and the ground. That is static friction. So whenever object is stationary, the friction between them is static friction. Fine. Now you can tell me, now that I've told you what static friction is, I'm sure you will be able to tell me what is sliding friction. Sliding friction, as the name suggests, means the object has to be sliding. Okay. In the earlier case it was static. Now the object should be sliding. Fine. So suppose I have this is the surface and this again is my object. And what I've done is I'm now sliding this object over this surface. So my motion is in this direction. In which direction will my friction force be? My friction will be in this. This is my friction. Okay. What kind of friction is this when the object is sliding over the other object? It is a sliding friction. So sliding friction refers to the resistance between two objects which are sliding against each other. Any friction between two objects, if they are sliding, then the friction between them is sliding friction. Okay, is it easy for all of you to understand? Yeah, Umesh will talk about the dynamic friction also. Just hold for some time. Okay, hold for some time. So this kind of friction is also called as sliding friction. This is also known as kinetic friction or dynamic friction. Does it answer your question? It is also known as kinetic friction or dynamic friction. Dynamic means something which is moving. Fine. So is this object sliding? Is this object moving? Yes. So anything which is moving is sliding. Rolling is also known as dynamic friction or kinetic friction. Kinetic means something that has some velocity, some speed. Okay, some speed in it. So that is called as sliding friction. Fine. So in this case, what kind of friction is existing? It is sliding friction. Okay. Now, you should be able to tell me the definition of rolling friction also now. What is rolling friction? Again, rolling friction means the object has to be rolling against another object. So what I've done, the same box, what I did is I have added two small wheels to the same object because see, suppose I have a book. Okay, instead of sliding the book, what can I do? I can actually put that book over 10 pencils. Suppose I have cylindrical, pencils are cylindrical. If I put it over 10 pencils and try to just push that book, the book will easily go forward. It is the same case. What I've done is I've taken this box, I've placed this box over two wheels, right? And now I try to apply some force here. When I try and apply some force, the box is going to move in this direction. So this is the direction of the motion. This is the direction of the friction. Now what kind of a friction is this? This is rolling friction. It is called rolling friction because now this box is rolling against this ground. This box is rolling against the ground, right? So what is rolling friction? It is a kind of resistive force that slows down the motion of the rolling body, and you can add that it is a kind of resistive force that exists between two bodies which are rolling against each other, okay? So is it easy? Are you all able to understand rolling friction, sliding friction, static friction? Okay, I hope I'm making it absolutely clear and easy for you. Okay, fine. So now let's move forward. Now it is the time for us to compare all the three friction. Okay, now look what happens in the case of static friction. This is a very, very important slide. Again, try and understand it carefully. If required, I'll repeat it. So this is the first case. This is the second case. This is the third case. Okay. The first case is what is known as static friction. The first case is of static friction. Now look what happens in static friction. The interlockings are perfectly interlocked into each other. Okay. How are the interlockings? They are perfectly interlocked into each other. They are not moving right now. To move it, we have to apply some force. Fine. Next. Look at this. The second one is called as sliding friction. Sliding friction. What happens in sliding friction? Is the object moving or is it stationary? In sliding friction, it is moving. Correct. It is moving. But if it is moving, what will happen when it start moving? The interlockings have started to get unlocked. They have just started. From the static friction where they were perfectly interlocked into each other, now the irregularities have just started to unlock. Okay. And look at rolling friction. The last one is of rolling friction. Fine. The rolling friction, what happens is, now because the two objects are quickly rolling against each other, there is very less time for the irregularities to interlock into each other. So in which case is you have more time to interlock? In the case of static friction, you have more time for the irregularities to lock against each other. That's why which is more? Which kind of friction is more? It is the static friction which is more. It is the static friction. In the second case, the irregularities have got slightly lesser time of interlocking. So the sliding friction is slightly less than the static friction. And look what happens in the case of rolling friction. In the case of rolling friction, the two objects are actually quickly rolling over each other. So there is no kind of friction is more, static friction is more. Which kind of friction is the least? Rolling friction is the least. And which kind of friction is in between the static and rolling? It is the sliding friction. Okay? So I hope that is making this concept very clear to you. Fine? Okay. Now let's move on to fluid friction now. What is fluid friction? First of all, what do you mean by fluid? Fluid, the term. What do you mean by fluid, this term? Fluid means something which can flow. Something which can flow is fluid, okay? Which is able to flow is called as fluid. So, gas can flow? Yes. Okay. Liquids can flow? Yes. So, in a way, we categorize gases and liquids also under fluids. Both gases and liquids are categorized under fluids. Okay. Just a second. Yeah. So both liquids and gases are actually categorized under your fluids. Both can be called as fluids. So what is fluid friction? Some friction which is offered by fluid is called as fluid friction, which is applied by fluids. So where all do you see fluid friction? Now suppose, understand that this the parajumper, he's coming down. So if he's coming down, what is his motion? Where is he coming down? Okay. Yes. Okay. Sanvi says a fluid is a substance that continuously deforms under an applied shear stress, external force. Fluids are the phase of matter. Fine. Very good. Very nice. Okay. Okay. So here, look at, understand this. I'm just adding something what you have already written in the chat. So here the motion, how is the para jumper coming down? The para jumper is coming down like this. So this is the motion, downward motion. So where is the resistance going to act? The resistance will be acting in the upward direction. Fine. So what is this resistance? It's only air. The medium is only air. So what do we call this kind of resistance? We call this resistance as air resistance. Okay. We call these resistance as air resistance because air is giving the resistance. Fine. So air is also a fluid. So air resistance is also called as fluid resistance or fluid friction. I told you in the first class, what do you mean by friction? Friction is a kind of like obstruction, some kind of huddle, some kind of resistance, right? Right? Some kind of problem which is not allowing us to actually move forward. So resistance is also the same. So that's why here, what is obstructing the motion? If the motion is downwards, the air is obstructing the motion. So in this case, it is air resistance, also called as fluid friction. Fine. Now, let's skip. Okay. What in which all situations do we find air friction playing a role? So suppose the aircraft is flying. Okay, this aircraft is flying. So if it is flying, let's say in this direction, this is the motion of the aeroplane, the aircraft. So the friction is going to be in the opposite direction. Where in whichever direction your motion is, the friction is going to be in the opposite direction. Correct? So the friction is going to be in this direction, in the opposite direction. Fine? So this is also called as fluid friction or air friction. Correct? Now, suppose if you're flying, do you want your friction to be more or you want your friction? I'm not asking on the ground, not on the ground. Of course, on the ground, it has to be a little, the friction has to be more in such a way that we are able to walk easily. But suppose you're flying. If you're flying and let's say while flying, you are getting more friction from the front because you are moving like this. This is your motion. So this is going to be your friction. Suppose you're moving like this, your friction is in the opposite direction. What will happen? You're not able to pick up that speed. You will not be able to pick up speed. Friction will restrict your motion. So you want your motion, you want your friction to be reduced. So what are the ways in which the friction can be reduced? Very important again. Now that you have understood what is fluid friction, understand how can you reduce this friction while you're flying. You can reduce the friction by taking a streamlined shape. What is a streamlined shape? Okay, a streamlined shape is something like this kind of shape. This, most of the birds, they take streamlined shape. Most of the aircrafts that you see, they are also having the streamlined shape. If you see the latest technology, the stealth aircrafts, they will also have a streamlined shape. So streamlined shape is a shape which will give you least friction. Okay, so you would prefer a streamlined shape. We will learn more about streamline. This is it. Okay, this is the streamlined shape. Why will you have or you would prefer streamlined shape? Is because now understand that if your shape is like this, it is called a streamlined shape. Look at the streamlined body. It's written here. So whatever airflow you are getting from the front, okay, all the airflow is going to smoothly go like this and exit. The airflow is coming, smoothly go and exit like this. Means it will not get stagnant at this place. It will not be stagnant at this place. This one, at the front portion here. No air will get obstructed or staggered at this place. Most of the airflow is just going to go and smoothly pass over this surface. So even our wings of the aircraft is also streamlined in shape. Fine. Okay. So first is, how do you reduce fluid friction? First is by having a streamlined shape. Okay. Vineet is asking thin on the top and broad at the middle. Yeah, something like that. At one end it has to be, from the front it has to be like this, from the front it has to be smooth. See, it can't be like this. It can't be a square shape like this or a rectangle shape like this, because what will happen? The air will come like this and it will find itself difficult to actually turn like this and go something like this. So the front surface has to be smooth. Okay, whether it is something like this or it is something like this, but it has to be smooth. It has to be smooth like this. It can't be rectangle. Have you seen any, even look at the birds when they fly. What do? They fold their wings, in the backward direction. They make their body, they make the surface area of the body as small as possible. When they are going on very, very long flights. They don't actually flap their wings when they're going on long flights, because if they expand their wings, what will happen? The wings will actually make their surface area more. So the more the surface area, the more will be the air friction. So you would like to have the least surface area when you're flying in the air. That's why all the birds will always fold their wings tight and close to their body when they are flying long distances. Correct? So this is the kind of shape that you would want in order to, something like fish. Yeah, exactly, Tanya. Something like fish only. Okay. Next is, so these are the things that, these are the factors on which the fluid friction will depend on. So if you take care of these factors, your fluid friction will be taken care of. So what are the factors? First is you have to take care of the speed of the object. Then the nature of the fluid in which they are flying, the air in which they are flying, or any medium in which they are flying. Secondly, the shape of the object. Shape, I told you. What kind of shape should it be? Streamlined shape. Now let's talk about the other factors like speed of the object and nature. Write down these 3 points somewhere. Make a good note of these points. So fluid friction depends on speed of the object, nature of the fluid, and shape of the object. Okay. Now let's see how the speed of the object is going to determine the fluid friction. What will happen with speed? Now, suppose if the aircraft or if the bird is actually flying at a very high speed, If you fly at a very, very high speed, then the air friction will be lesser, because it is only for a very small time that you are actually experiencing that amount of air or that air friction. If you increase your speed, what are you doing? You're reducing your time in the air. So by reducing the time in the air, you are reducing the friction, right? So if you quickly pass through, suppose there is some fire, what do? Will you walk slowly, or you will try and walk and cross the fire quickly? You will try and cross, pass the fire as quickly as possible. So the faster the speed, the lesser the effect of air friction. Okay, is that understood, the first point? Okay, let us talk about the second point now. The nature of the fluid. Now look, the more viscous the liquid is, the more will be the friction. What do you mean by viscous? Viscous means, let's say water and honey. So which is more denser? Viscous means denser in a way. Honey is more denser, or your water is more denser? Honey is more denser. So honey is more viscous. So this is a new word that you're learning probably today, okay? Honey is more denser. Honey is more viscous. Viscous means denser. So the nature of the fluid matters. Suppose if the liquid or the fluid in which you're traveling is more denser, then friction will also be more. Will you be able to swim in water easily, or will you be able to swim in honey or any other more denser medium easily? You'll be able to swim easily in water. Why? Because water is a less denser medium. So the more the denser, the denser the medium, then the more the friction. Okay? So if you have to reduce friction, you have to choose a medium which is less denser. Correct? And the last point is the shape of the object, which I told you how should be the shape of the object in order to reduce the friction. The shape has to be streamlined shape. The shape has to be streamlined shape. So these are the three important points which you have to take care. So if I ask you, what should be the speed of the object if you want your friction low? If you want your friction to be low, what should be the speed of the object? Your speed of the object should be high. What should be the shape of the object for your friction to be low? Your shape of the object has to be streamlined shape. Streamlined shape. Okay? And what should be the nature of the fluid? The nature of the fluid has to be less denser or less viscous if you have to reduce the friction. So these are the three important points or the factors on which the fluid friction will depend on. Okay, someone is asking, what is the meaning of streamline? Streamline means this shape. This kind of shape is called as streamline shape. The shape that you see here, this shape. This is a streamline shape. This one. This is a streamline shape. Right? Suppose if your shape is something like this. Let's say your shape is like this. Okay, let's say you have these wings here. Again, these wings. Can you have a shape something like this? A square shape or a rectangular shape something like this? No. Why? Because whatever air is coming, all the air is going to be stagnant here. So more the air that touches your tip of the aircraft here, or the tip of the, let's say any bird which is flying, it will not allow the bird to fly faster. It will not allow the aircraft to actually move faster, because the friction is more. If the friction is more, then the movement will be less. Right? So this type of shape is called as streamline shape. Fine. So we have finished the chapter, which is friction. It was a very, very small chapter. I hope you've understood all the concepts in this chapter. We are open for any questions. We have 10 to 15 minutes right now. I can take up any questions if you have. Right? You want me to repeat something? I will. Do let me know. Write down your queries in the chat box. And I will be uploading this video on the YouTube. Please go through the video again. Any doubts that you have, please write that down in the comment box so that I'll give you immediate solution. Okay, yes, Tanya, you have to write all the notes. See, I'm already giving you all the presentations, everything is available. So, what you should do is pick up important notes like factors of reducing friction, factors of increasing, how to reduce friction, how to increase friction. So, I've got whatever I've covered in points only. Okay, I've not covered in some lecture sort of form. Okay, secondly, what is the fluid friction? So you can make out questions from this chapter. First of all, what is fluid friction? What are the factors on fluid friction? Depends. Fine. And so all these, take out some notes, write down all the points in your classwork. I want all of you to maintain a good class notes, and also in your homework, you'll only be doing your homework questions, only your exercise questions. Nothing in the homework copy. Okay. Any other thing? Friction DM. Okay. Another small request is all of you should write down your names, not your parents or not your RG gamer, HG gamer or whatever, or these hanky panky names that you keep writing here. Please don't write any fancy names. Please write your own name. Okay. Someone is asking me, friction is a non-contact force, so there is no friction in air. No. Okay. Understand this. The question is very good. He's asking, is friction a contact force? Yes, this is what we learned in the first chapter. Friction is a contact force. Okay, so in the case of air, the aircraft or the bird is in contact with dash. It is in contact with air itself. So the bird is in contact with air. The aircraft is in contact with air. Okay, fine. So that means both of Acha, Arvind, this is you. Fine. Okay, fine. So, yeah, do write your name. Yeah. So that means the object is in contact with the air. So that means air and the object, air and the aeroplane, air and the bird are in contact with each other. So that means there is a contact, right? So there has to be friction. So friction is always a contact force, whatever it is. Friction will always be a contact force. Okay, then. See, I've already forwarded you all the marks that I got yesterday. Okay, that was just a test for you to demonstrate how in future the test is going to be. Okay, I've already, at least I think 26 of them have appeared in the test. So I've already forwarded you all your marks. And suppose some of you were not able to. Okay, can you hear me now? Can you hear me now? Okay, how many of you, beta, because okay, some of you who have not got your marks is because I haven't received any response from you. I have to receive your test papers, then only I can correct it, right? But I haven't received any test papers. I'll check as to what is the problem, why you are not able to, maybe at your end you were not able to submit, or was there any problem with, with my settings. I will check it, but it's okay. Do not take it, it was just a test for demonstration. What I will do is, we will conduct another, multiple choice, another test which will include all the multiple choice questions or short answer questions. And in that, I will let you know as to what is the exact setting that, you are supposed to keep while submitting your test papers. So do not worry about it. Were you able to open the form, the Google Forms properly? No, I will inform you about the test. Not in this week. Maybe next week. Not in this week. Okay, Sanvi is asking, can you give me an example to support that friction leads to wastage of energy? Yes, see, suppose the same example, very same example of your cycle. Suppose if you do not let's say oil your cycle properly, and if the friction between the parts of the cycle increases, then what is going to happen? It is going to create it is going to make a lot of noise. It is going to give out a lot of heat, and then it will not work. So efficiency, what do you mean by efficiency? Efficiency means output. So suppose you were able to ride your cycle and you were able to go to school. Now what is going to happen? Because you did not oil your cycles, because there was so much of friction between the parts, what would happen? The wear and tear will start, and eventually you will not be able to go to school, or you will not be able to even use your cycle, right? So this is called reduction of the energy or wastage of energy, right? Sunny, does that answer your question? That is actually wasting of energy. You're not getting so much of output as you wanted. Okay, fine. Then is there any other question? Otherwise you can leave the stream. And next class we are going to only discuss the question answers of this chapter. That's all. Yeah, all of you can leave the stream. Chalo. See you in the next class. Take care. Yes, you can leave. You can leave. Okay, Sanvi, why is it difficult to walk on an extra smooth floor? Because if the floor is extra smooth as you've written, then what will happen? Then the friction also would be extra less. Okay? If this floor is extra smooth, then the friction also would be extra less. So if the friction is less, then your movement is going to be more. If your movement is going to be more, means you will slip easily. Right? So that's why it's not comfortable. Sachin, you would have got your marks in through your Gmail, and I have also forwarded a copy of your marks to your class teachers.